All right, we're back. We're going to be on page 4, note 16, Calc C. We're talking about parametric equations. And this is kind of like a little summary of some of the things that we've said already. X and Y, you want to consider them independent of each other. X is telling you left and right stuff. Y is telling you up and down stuff. And because of that, dx dt is going to tell you your movement in the horizontal direction with respect to time, usually. So it's basically the horizontal velocity. And you can have a horizontal acceleration, right? So dx dt could be positive, meaning you're going to the right. The second derivative, like x double prime, let's say, could be negative, which means you're moving to the right, but you're slowing down. Your speed is decreasing in the x direction. So you can have that interplay. And then y is going to tell us basically the same thing, but except for vertical direction, right? So if dy dt is positive, you're moving up. If dy dt is negative, you're moving down, that kind of thing. So let's see if we can do this. So I made this graph. It's not great, but whatever, gets the job done. And we want to, there's a lot of time intervals. All right. So on each time interval, we want to say what dx dt is doing, dy dt is doing, and then the motion. So I think we got this. The thing I'm struggling with right now, I got you. I couldn't figure out where to start. So here's t equals 0. We go this way, right? From 0 to 2. So our time interval is 0 to 2. Not really concerned about the endpoints where it looks like we have some not differentiable points there. But dx dt is less than 0, which means you're moving to the left. Dy dt is actually 0 because you're not moving up or down. And because of that, you are moving left. And that's all we know. You're moving left. That's it. The next time interval is going to be, I don't know, do I need to keep highlighting? I'd like to not do that every time, but 2 to 5. So 2 to 5. So we're still moving to the left. So dx dt is negative. Now you're moving down, so dy dt is also negative. So you are moving left and down. And now our next interval, I guess I'll just alternate colors. Is that going to work? Are there enough? Purple, whatever, purple, whatever. It's not, there aren't enough. Okay, so we're moving to the right this time. So our time interval is 5 to 7. Gotta get that right. All right, dx dt is going to be ew. Okay, dt is positive because you're moving to the right. Dy dt is still negative. So why am I writing equals? Is less than 0. All right, so now we're moving to the right. And you're moving down. Actually, so I think maybe on my website, I definitely made this in GeoGebra at some point and like had a point do this. And you can like watch it move if you want to. GeoGebra is the way to go. I mean, if you watch the analysis notes, we do a lot of stuff with GeoGebra because it can make things move. So now x is not moving left or right. It's strictly moving down. So dx dt is 0. Which is good. And then dy dt, we're still moving down. So dy dt is less than 0. So now you're just moving down. You're not moving left or right, but you're still moving, right? For it to be not moving, you need dx dt and dy dt to be 0 at the same time, which doesn't really happen on this thing. So next, I'm going to switch color here because we don't have enough segments to go all the way around just using 2, which is unfortunate for us, I guess. So 8 to 11, 8 to 11. Dx dt is positive because we're going to the right. So this is just the analysis you want to do. Dy dt is 0. Can we go faster? We're just moving right. And then 11 to 13, I'm going to switch back to what color? I don't know what color this is. I mean, it's blue-ish. So 11 to 13, we're moving strictly up. So dx dt is 0. It's not moving left or right. And then dy dt is positive. So up. And then finally, 13 to 14. So you can see like we have different time intervals for different distances. So you're actually going different speeds as you move along here. So remember, speed is the magnitude of velocity. And the velocity here, we would have to have like a velocity vector, a dx dt comma dy dt. We're going to talk about vectors at some point, and when we do, that's going to be relevant. So 13 to 14, moving right and up. 13 to 14. So dx dt, since you're moving, since you're moving to the right, dx dt is greater than 0. Since you're moving up, dy dt is greater than 0. Going to the right, and you're going up. So this kind of analysis, super useful. Don't flip out when you see these kinds of things, because it's picture the motion. If you can picture the motion, you can tell me if something's moving to the left or the right, if it's moving up or down. Therefore, you know what dx dt, dy dt are doing, because you're able to make that kind of a, I don't know, you can make those generalizations. You do end up using the candidates test sometimes. You do like, what's the farthest left that you get? What's the farthest right that you get? What's the highest it reaches? What's the lowest? That's candidates test, but you're only, if it's left and right, you're only using the candidates test on x of t. If it's up and down or on the y-axis or whatever, it's candidates test, but only on y. You sometimes say like, does the particle or whatever ever reach the x-axis, right? So if it starts above the x-axis and you find the absolute minimum, if the absolute minimum for y is below it, you must have reached it because motion should be continuous. So all kinds of candidates test things come up. Basically anything you do, fundamental theorem, right? If you know dx dt and you know a point, you can find x of t. If you know dy dt and you know a point, you can find y of t, or you can find a specific value using fundamental theorem. So a lot of good stuff. And again, all of parametrics is basically an excuse for you to do non-parametrics twice per problem. So keep that in mind while you're thinking about them before you let it overwhelm you, because it's not overwhelming if you think of it that way. All right, I'll be back in the next one, and we'll be doing more. So see you there.